is Mrs. Cucci's College Now Pre-Calculus class. The topic we are focusing on is still partial fractions, so it's part 2 or day 2 of partial fractions. And our objective is still going to be decomposing rational expressions into partial fractions. So yesterday we went through 2 examples, and today we are simply just going to do 2 more. So we are on example number 3. So here we go. The example is 6x cubed plus 5x squared minus 7 all over 3x cubed minus 2x minus 1. The difference between this example and the ones from yesterday is that the degree of the numerator is greater than that of the denominator. Yesterday we only had examples where the degree of the numerator was less than the degree of the denominator. So what we need to do is find an equivalent expression in order to make the degree of the numerator less than the degree of the denominator. So how we do that is we are going to divide. All right, so we look at this 3x squared and see how many times it goes into 6x cubed. And we see that is 2x. 2x times 2x squared is 6x cubed. You also have to multiply through the rest of the terms. So this is regular division, long division. Okay, so we look at the 3x squared again. That goes into 9x squared 3 times. So 3 times your trinomial on the left there. (8x minus 4). So our new equivalent expression can now be written as your 2x. I'll write it here and then I'll erase 2x plus 3 plus the remainder all over what you divided it by. Okay, so I'll rewrite this. I'm going to clear the screen and rewrite this. So we're going to take this fraction and decompose the fraction. And we will bring it back with the 2x plus 3 at the end. So here we go. So we have 8x minus 4. So now it is a fraction where the degree of the numerator is greater than that of the denominator. Okay, so we know when we factor 3x squared minus 2x minus 1, we get 3x plus 1. And x minus 1. Now we want to combine those 2 fractions on the right, so we're going to multiply this first fraction by x minus 1 over x minus 1 and the fraction to the right in order to get common denominators. Which leaves us with Okay, so now that we have this, apologies for how this looks. We're going to delete it in a second. We can now set the numerators equal to each other. Okay, so I'm going to delete this. I'm going to scroll up. Okay. So we can set 8x plus 4 equal to a x minus 1 plus b 3x plus 1. And we know, both of our examples yesterday, we went through this, that this equation is now true for all of x. And we want to pick x's such that we'll eliminate either the a or the b, so we can solve for that a or the b. So let's look, a is being multiplied by x minus 1. So if we set that x to 1, this whole term will multiply to 0, and we'll only be left with the b. So let's go ahead and do that. So first I'm going to let x equal 1, and we will have 8 plus 4 equal to 0. Solve b equals 1. All right, now over here, I'm going to look at what's being multiplied by b. 3x plus 1. So 3x needs to equal negative 1 in order for that to multiply to 0. So we're going to let x equal negative 1/3. On the left, you could just put it into your calculator, leaves you with negative 20 over 3 equals a negative 4 over 3. And we get a equals 5. So we have b equals 1, a equals 5. So over here, we can go back to our decomposed fraction. Just plugging it in. And then our final results. We can't forget about the 2x plus 3 plus 5 over 3x plus 1 plus 1 over x minus 1. All right, so pause here if you didn't copy everything down. So let's just circle our final answer for example number 3. Okay, so let's move on. Oh, and one more thing for all of these examples, we talked about it yesterday in the last video. To check to make sure your answer is correct, you want to use that table feature on your calculator. So for f1 of x in this case, you would put in that original fraction, the 6x cubed plus 5x squared minus 7, all over 3x squared minus 2x minus 1, into your either f1 of x or your y1. And then in f2, you want to put in that 2x plus 3 plus 5 over 3x plus 1 plus 1 over x minus 1 to ensure that those table values are exactly the same. And example 4, this will be our last example for this lesson. And what we are going to show you in this lesson is a way systems of equations can be used to decompose rational expressions. So we're going to look at the same exact example from example 2 from yesterday and incorporate systems of equations. Okay, so recall we had 7x squared minus 29x plus 24 over 2x minus 1, x minus 2 squared. Okay, and we set that equal to a over set that equal to a over 2x plus 1 plus b over x minus 2 plus c over x minus 2 squared. So again, we're going to use systems of equations to decompose this rational expression. So here we see we can set our numerators equal to each other. I'm just going to move this up so we have more space. So I skipped a step here because we already did it in example 2. So you should be familiar with how I got to this step. Okay, now I'm going to take it a step further, and I am going to multiply out the binomials. So and now I'm going to distribute those A, B's, and C's. All right, and now we would like to combine like terms. So there's an x squared, and here's an x squared. So we'll combine those constants to a plus 2b x squared plus, let's look at the next. So we have, there's an x, there's an x, there's an x. So let's combine these. And then our constants. For a plus 2b minus c. Okay, and I'm also gonna, I didn't write over this left side each time, but I'm gonna bring it down now. And now I'm going to show you what we have here. We have the left side of the equation and the right side in the same format. So look at this 7, we can set equal to a plus 2b. This negative 29, we can set equal to negative a minus 5b plus 2c. And this 24, we can set equal to 4a plus 2b minus c. Okay, so we're going to set up 3 equations, exactly what I just said. So I'm going to move the page up. So So if you follow those arrows I had just drew, now we have three equations, a system of equations. Next step is you would solve for the solutions using any of your methods of solving a system that we've learned for this unit of three equations to confirm the answers that we had found in exercise 2, which was A equals 5, B equals 1, and C equals -1. I'm sorry, C had equals -2. So you would get the same result the decomposition would be 5 over So again, take a minute at the end of this and try to go through solving that equation. It's a pretty simple system of equations to solve using either elimination, substitution, or your matrices. Okay, and that ends our lesson on partial fractions. So come to class with any questions. Bye.